In a certain experiment, 28 milliliters of 0.25 molar nitric acid and 53 milliliters of 0.32 molar potassium hydroxide are mixed. What is the concentration of H plus plus OH minus H plus or OH minus in excess after the reaction goes to completion? Remember, this is a strong acid and a strong base. So that means that it's the net ionic equation is this. So I will need to first write down my known information, 28.0 milliliters of 0.25 molar HNO3. It's a great practice. Go ahead and start writing down known information as you go so that you know what to do. And you can refer back to this stuff. This is a lot easier to refer back to than this stuff. Alright, so for the first part, I want to convert, and I want to find out the number of moles, because what's going to happen is these two are going to neutralize each other. One of them is, we're going to run out of one before we run out of the others. So we need to identify the limiting reactant. So we need to first identify the limiting reactant. So if I take 28 milliliters of HNO3 and then I convert it to moles, I have 1,000 milliliters down here for HNO3 and then 0.250 moles for HNO3, and I will find out that I have 0.00700 moles of H plus ions. I get H plus ions because I skipped a small little step. There's one hydrogen here, so this will ionize out and become an H plus ions. I don't care about this NO3. I really don't. It's a spectator ion. I'm only concerned with the H plus. So let's do it again to find out the other one, and we'll move on from there. And I find out it's 0.0170 moles of OH minus ions. Sweet. Okay, I should be able to tell right now which one's my limiting reactant, and that is this one, because it is the smaller one. So that means that all of these will be consumed. All H plus ions will be consumed. And they will react to form with the exact number of moles of my hydroxide ions. And then I will have excess OH ions. Okay, so I did the first part, but it asked me to find the concentration. It asked me to find the concentration of the OH ions. So now I'll have to do a little bit of math trick where I take 0.0170, that's this number, and I'm going to subtract it from 0.00700. That gives me 0.0100 moles of my OH ions in excess. Whoops. In excess. Very, very nice. One last trick, though, is I need to remember my total volume as well. Remember, I added 28 milliliters to 53 milliliters, so that my final volume is going to be the combination of the two. So I need to take 28.0 milliliters and add it to 53.0 milliliters and add those together as well to make 81.0 milliliters. Now I have moles over liters, so just take 0.0100, divide moles of hydroxide, divided by 8.10 times 10 to the minus 2 liters. I punch that into the calculator, and I will now get 0.123 molar hydroxide. That's the concentration afterwards. So the concentration of base, or my hydroxide ions, after neutralization. Oh my goodness, I didn't show that to y'all. Oh my gosh, I screwed up. Well, there it is in its completion. Very nice, nice little problem, and this is a pretty tough one, so good job for understanding it.